Okay, so we're talking about these things called complex rational expressions. Um, let's go ahead and chat about what those are first, and then we'll talk about simplifying them today, because that's pretty much it. So, um, so what is a complex rational expression? Does anybody remember what a complex rational expression is? Okay. Complex means like, I know it means difficult, right? But it could also mean like multiple parts or something, right? It's got a bunch of parts to it. And so here's a regular fraction, right? Call that a regular fraction. 1/2. But a complex fraction would be a fraction that has fractions in it. Math teachers thought, students like them so much, we should just double the fun, right? So these are fractions. Well, we're talking about rational expressions, though, right? So like, here's a normal rational expression, right? Just a fraction of polynomials. But here would be a complex rational expression. Okay, so that's what a complex rational expression is. You might like wonder like, why would anybody do that? Well, it just kind of, it's a reality. We need to divide sometimes, don't we? Right? Dividing happens, and sometimes the things we're dividing are fractions, right? So basically, what a complex fraction is just taking one fraction and dividing it by another. So it's another way to write it. But basically, that's all it is. You're just dividing fractions. Is good? Should I pause or should I proceed? I even got permission from you. That's awesome. I'm ready to go. Let's do it. Let's go. Let's go. Is that how you guys say it? All right. Let's go do an example. Write down example 1 here. Okay. Okay. So here we go. Before I start this problem, let's review here a little bit. Let's say I have like 3/4. Don't write this. Just watch. I can multiply the top and the bottom by any number I want to. So, Amber, pick a number. 2. Okay. So if I multiply the bottom by 2 and the top by 2, don't you guys agree that 3/4 and 6/8 are really the same thing? Okay. So you're allowed to multiply a fraction by anything you want to, so long as you get to top and bottom. It just kind of unreduces it, so to speak. Let's talk about another interesting fact. Now, let's say I have 3/4 times x. Well, I'm just going to say it like this instead. What can I multiply this by so that I would cancel out the 4 and just get 3? So 3/4 times what would just cancel out the 4? That would make 0. So if I put 0 here, that would give me 0, right? But I want to multiply this by something so that the 4 goes away, but the 3 stays. Multiply it by 4. Okay. So the reason for that is because when you multiply a fraction by its denominator, what happens is 4 divided by 4 is 1. They cancel out, right? Okay. So we have a couple of facts there that we're going to make use of. So what we have here, you guys, is we've got one big fraction. There's my big fraction bar. There's the top of my big fraction, and there's the bottom of my big fraction, right? So I've got a big fraction here. You guys see it? But we also have miniature fractions inside. I'll make those green. Here's one of my mini fractions, and here's one of my other miniature fractions. Now what I want to do is I want to simplify this so it's no longer fractions inside of a fraction, but just a normal fraction. So here's what I'm going to do. Let's say I want to get rid of this 4, because I don't want this to be a fraction here. I want it to be just a normal number. So if I want to get rid of this 4, what would I have to multiply this fraction by? I would multiply it by 4. You could think of that as 4 over 1, okay? But I would multiply it by 4, which I'm allowed to do if what? No, I'm not hearing it yet. You're allowed to multiply this bottom here by 4 if you also multiply the top by 4. Okay? So why am I multiplying by 4? So that goes away. But we have to do it to the top also, right? So we have 4a over 9 over what now? Okay, would you guys agree that's looking a little bit simpler now? Because one of them's not a fraction anymore. So what do you think I'm going to do now? We're going to multiply the top and the bottom by 9 now, right, to cancel out the other fraction. So I want to cancel out the 9, so I multiply by 9. But whatever I do to the top, you have to do to the bottom, otherwise your fraction is not balanced. Okay, so on the top, these go away, right? And now we're left with what on the top? 4a, that's all that's left now. And on the bottom? And in this case, that's simpler, right? That we've simplified it, but we can actually go a little bit further. Sometimes you can, sometimes you can't. What can we do here? No. It's tempting because they're both nice squares right here. What can we do? Yeah, there's an a on the top and an a squared on the bottom. So we can reduce to make 4 over 9a. So the main trick is this, right? You have little fractions inside of a big fraction, right? What you do is you multiply the top and the bottom by the little denominators. You may or may not have to reduce at the end, okay? Let's do I feel like you guys might need to practice that one, so I'm going to skip to here. I want you guys to try that real quick. Take a second and try that out. All right, so Haley, what do we do first? Cool. In conductor, if we do that, what do we have? Yes, on the bottom we have 3. I'll agree with that. What about the top? Yeah. There you go. And we're done. That was easy, right? Now, there is another way to do this, but the only reason why I don't like to teach this first is because this way we're going to be able to use for every problem we're doing today. This other way sometimes is faster, but it only works when you have one fraction over one fraction, okay? We're going to be doing some problems that look like this later on today, where you have one fraction over two fractions. This method I'm going to share with you won't work for this particular situation. But I want to share the method with you anyway. So here's what it is Quinn had been saying, and I mentioned earlier too, that doesn't it just mean one fraction is being divided by another fraction? So technically you could just write it like this, right? And then you could do same or keep, change, flip, right? And then cross off your A's and you got your answer. And so that can be faster. What if we applied that to this one here? Be pretty dang quick. You'd have A over 4 divided by 3 over 4. Keep, change, flip. Got your answer, right? So it's a little bit quicker for the situations where you have one fraction over one fraction. Okay. So you're welcome to use it if you like, but just remember it will create some issues if you try to apply it in the other circumstance. All right, let's go ahead and do this one. So this one I'm going to just raise the standard a little bit here. It just looks a little bit uglier, but it's really the same type of problem. Okay, so my big fraction here is that over that, and I want to get rid of these denominators here out of each of those little fractions. So I'm going to multiply the top and the bottom by what? There you go. That cancels, that cancels, that cancels, that cancels, and I'm left with 9 over 3x, which reduces more to 3 over x because 3 goes into 9 3 times, right? Not too bad. So once again, you could have done this divided by this, keep, change, flip, and cancel method. That would have worked fine as well. I'll let you guys decide which one you want to do. All right. So that's not the one I want you to do. Let's back up a bit. All right. Why don't you guys try that one real quick? Okay, so Jason, what did you do first? Good. So we have the top, we have the bottom, and we're going to multiply it by one of the little denominators. We're going to start with the m over 1 here. That's fine. So in this case, they go away, right? And we're left with m plus 3 over m cubed over m plus 3. So now we have this over this. Nick, what would we do next?
I guess we would do the m plus 3 over 1.
Good. Yeah, it doesn't matter what order you do it in. I think maybe some of you guys might be looking thinking, I'm not getting it, but that's because maybe you did the m plus 3 first, and then the m, but it doesn't matter. You'll get the same answer either way. So in this case, these go away, right? And now we have this. I doubt they would leave the answer like this. My guess is they would probably box the answer out and FOIL it or whatever, and you would get m squared plus 6m plus 9. That's a box problem. Let's see how they write their answer. I'm curious. Yeah, they went ahead and boxed it out there. All right. So there's that. Uh-huh.
Why is it M cubed?
Huh?
Why is it M?
Why is it M cubed? Let's see. So when you, on this person chose to start by multiplying the top and bottom by m, right? Now I don't know, did you do that first or second?
Second.
Okay, it doesn't matter. But when you do multiply by the m, you see how we have an m squared down here? When you multiply this one by m, you get m cubed. Yeah. All right. So we're gonna take it up a notch now. So the problems we're gonna look at now are like not just one fraction over one fraction, but one fraction over two, and maybe two fractions over two fractions. So let's write down example 3 here. Okay. So I've got 3 denominators that I want to get rid of here, right? I want to get rid of that 8, I want to get rid of the 2, and I want to get rid of the 4. Now, if you're kind of smart about things, you can make less work for yourself, okay? What should I multiply by first? No. You want to multiply by the 8. Does anybody know why we should multiply by 8 first?
Because it's easy.
Why is it easier?
You do.
So I'll tell you why. When you multiply by 8, will that cancel the 8 out? But it will also cancel that 2, and it will also cancel the 4. Does that make sense? No? I'll show you. But here's the big takeaway I want you guys to get. I'll show you why it works. But if you multiply by the bigger denominator, it's more likely to cancel more stuff out. Okay? So let's do it. I'm going to start by multiplying everything by 8. Now here's something that's a little bit different. Why don't you guys go ahead and put this in parentheses, okay? And put your 8 over 1 out here. You need to distribute this to both terms in there. Okay, so I'm going to rewrite it. The top will look like what now? Just 1. Okay. Now on the bottom, what will I have? 8u over 2 plus. Okay, now I could multiply by 2 and 4, but do you guys see what can happen here instead? What can I do here? You can just divide them, right? What's 8 divided by 2? 4. So instead of 8 over 2u, now it's 4u. How about the next one? 8 divided by 4 would be 2u. What's my final answer? There you go. So now, if you started by multiplying everything by 2 instead of the 8, like let's say instead of multiplying everything by 2, it wouldn't be wrong. You just have to do more work. Because if you multiplied everything by 2, yes, you'd cancel this out, but that 2 would not cancel out the 4, and it wouldn't cancel out the 8. So you'd have to do more multiplication to keep canceling them out. But if you start by multiplying by the bigger one, you can save yourself some work. Okay? But there it is. So the only difference here between these types of problems and the ones that we just did is that when you do your multiplication, you're distributing it to both fractions instead of, you don't, so how you wouldn't want to write it is like this. If you did this, somebody will probably make the mistake of only multiplying these and do nothing to this, right? So that's why I said, put parentheses. Or if you want, in the past, whenever I've taught it before, I just sometimes I just put it on all 3. That's the same thing as distributing it. You can do it that way too. But the point is that it goes to both fractions, okay? Let's do another one before I set you loose on some of these. Write that one there. So I've got 3 little denominators that I want to get rid of. I want to get rid of x squared, I want to get rid of x, and I want to get rid of x plus 5. Which one should I multiply by first? In other words, which one will cancel more stuff? X squared will cancel more stuff. Okay? X plus 5 will only cancel itself out. But that x squared will cancel itself out, and it will also cancel out the x. So let's go ahead and start by doing that. So I'm going to put parentheses around my bottom, and I'm going to multiply the top and the bottom by x squared. Okay, so in this case, those go away, and I'm left with 5. And if I distribute here, I end up with 25x squared over x plus 5 minus x squared over x. But we can reduce this one, right? What does that reduce to? Just x. So x squared over x can just become x. So multiplying by x squared, I ended up canceling out 2 fractions. All right. I'm going to rewrite it because I'm out of space. Because we're not done yet. Now what am I going to multiply by? We're going to multiply everything by x plus 5. So let's put that in parentheses. And let's put x plus 5 here and here. All right. So what am I going to have on the top? Sure. So she chose to distribute, so that'll work. 5x plus 25. Now on the bottom, I'm going to distribute this in. Okay. So I just distributed the x plus 5 into the fractions, or the 2 terms there. So what do you guys see we can do now? Yep, the x plus 5's here go away. And we're left with this 25x squared minus x and x plus 5. So that's pretty simple. I doubt they would leave it like this because there's some distribution we can do. So I'm going to go ahead and do the distribution and stuff, but it's not a complex fraction anymore. It's just a simple fraction now. But we can go ahead and simplify this a bit. So if you were to distribute this negative x into both, what you would end up with is 5x plus 25 over 25x squared minus x squared minus 5x. Oh. And then I see I've got 2 like terms here that can be combined. And we're good to go. Can I erase? So, I'm going to give you guys 2 practice problems to do. And that should wrap things up for us. So there's 2 problems for you guys to try out. First one's a little bit easier. It's just all monomials. Bottom one has a binomial. Pick up the challenge a little bit. There you go. I'll give you guys a little bit of time to work on those, see what you get. So what do we do first on this number 7 here? Sure. Let's multiply by 4. Okay, so we're going to distribute that in. And by doing that, we get 4x squared over 4 plus 16 over x over 4x. Now, here's the mistake I'm seeing as I come around. A lot of people, when they're distributing this 4 in, they're multiplying that 4 by the top and the bottom. So what they're getting is they're putting, like if they did that, they would have gotten 4x squared over 16. You don't do that. We're multiplying by 4 over 1. And when you multiply fractions, it's top times top, bottom times bottom. So you end up with 4x squared over 4. Okay? So you don't multiply that number times the top and the bottom when you do that distribution, just the top. Okay? After you do that distribution, you reduce. So you have x squared now. Okay? So I'll pause there and let you guys keep working because a lot of us aren't done yet. But I just wanted to give you that little hint. When you do that multiplication, you only do the top of the fractions. So I'm going to put the answers up real quick so you guys can check your work. These are what we should have gotten ultimately. Okay, I saw a few people getting number 7. I didn't see anybody with number 8 yet. So let's start with number 8, and then if we get some time, I'll go back and I'll do 7 as well. Okay. All right. My pen at. Okay, so what I'm gonna do is what would I multiply by first to get rid of the most stuff? So 3 will cancel out 3. Will it cancel out 9? It'll reduce the 9, but it won't get rid of it completely. We got 5 minutes.
No, we don't.
We don't? Oh, not 8:34? Okay. My bad. Okay, I think we'll stop here then. I'm not going to go through it because bell ring. I'll see.